Hi guys, welcome to my channel. In this video we are going to analyze a question. It's about structural analysis. The question will be analyzed due to moment distribution method. Let's solve the question. First I'm going to find the stiffness factors K and B. That will be equal to 4E times 2EI. You can see inertias are different. So over 6, and it will be 8EI over 6, and for KBC will be equal to 3EI over 6, 3EI over 6, and for distribution factor BA is equal to 8EI over 6, 8EI over 6, plus 3EI over 6 will be equal to 0.73, and when I take from the subtract from the 1, I will equal to 0.27. This is for distribution for BC. And now I'm going to write the distribution factors. This is fixed, so it is 0. This is roller is 1. So this is 0.73, and this is going to be 0.27. Let's calculate fixed end moment. Fixed end moment from A to B. That will be WL square over 12 times 4 times multiplied with 6 square over 12 will be equal to minus 12. Okay. And for fixed end moment, BA will be equal to 12. For fixed end moment from B to C, that will be 3 PL, 3 times 20, 3 times 20 times L is 6 over 16, and that will be equal to minus 15. Now I have my moments, so if I have moments, I'm going to write on the table and solve the question. So I'm going to write on the table like this: minus 12 and minus 15, and of course 0, and I'm going to distribute them. This is minus 12 times 0, it is 0. Minus 12 and minus 15, it is minus 3. When I multiply with this, I'm going to obtain 2.19. Take the negative of that also. I actually can write here. Multiply with 0.73, its own distribution factor, and multiply with minus 1. Will be equal to 2.19, okay? And this is going to be 0.81. When I carry over this is going to be 0. That will be 1.095. Okay, 1.095. Let's take the summation of the moments. That I'm going to take the summation of the moment from fixed end moment until the last row, and that will be minus 10.905, and that will be 14.19. That will be minus 14.19, and that's going to be 0. So now I have my moments. You know that the first table, we assume that there is a force here. Okay, we assume that there is a force here. Okay, we assume that there is a force, so we are going to solve as normal, yeah, without sideway. And so now I'm going to find the shear to calculate that R value, okay? For the shear, that is going to be something like this. This is 10.905, and I have an AX, and this is also, it will be this direction, 14.19. I have a force here, 24, at 3 and 3, okay? For AX will be equal to 10.95 plus 4 times 6 times 3 as 24, this force, okay, minus 14.19. Excuse me, 14.19. When I divided with the length of this member, and I will obtain as AX 11.46. If it is 24 minus AX minus R is equal to 0, so R will be equal to 12.54. R is equal to 12.54. Okay, now I find the first R, then I'm going to find R prime. So now I'm going to solve the question with Sideway. I'm going to assume a fixed end moment as minus 20, for example. Okay, it's minus because it is something like that, you know. It's going to make a shape like that, right? Then I will have a delta here, and this is at this direction, so it is negative. And now I write my fixed end moment. I'm going to write the distribution factor. Distribution factor also will be the same. There is no any change in the distribution factor. And this is 1, 0, and 0. Now I'm going to distribute the force. When I distribute the minus 20 with 0, this will be 0. And minus 20 with 0.73, this will be 14.6. And this is going to also be 5.4. Actually, I can show it here how it's going to be. Minus 20 multiplied with 0.73 multiplied with minus 1 will be equal to 14.6. And minus 20 multiplied with 0.27 and multiplied with 5.4, sorry, equal to 5.4. Multiplied with minus 1 is equal to 5.4, okay? So now I'm going just to carry over this to that direction. 14.6, that will be 7.3, I guess. Yes, 7.3, and this is going anything will be here. This is, I cannot make any carryover here because I used the modified formula to find the Stevens factors. Okay, and then the summation of moment will be minus 20.7 and minus 5.4 and 5.4. Okay, summation will be here from here until the last row. In every question it's like that. So now I find the moments. So let's find the shear and AX again. For AX, it's going to be something like this. For example, I have here, why I draw wrong. I guess it is better. For now, this going to be, I have two moments at the same direction, 12.7, 5.4, okay? And this is also AX. 5.4 plus 12.7 over 6 is equal to 3.0166, okay? This is my AX. And now R prime, one second. R prime minus 3.0166 is equal to 0. So R prime is 3.0166. And now I also R prime, so I'm going to take the ratio of that. C is equal to R over R prime. And this will be 12.54 over 3.0166 will be equal to 4.156. And now let's find the moments. To moment AB, minus 10.905 minus 4.156 times 12.7 is equal to 63.698. Of course, this is negative. For moment BA, that will be 14.19 minus 4.156 times 5.4 and will be equal to minus 8.2524. Okay, and of course this is keeps fit. So moment BC will be equal to minus 14.19 plus 5.4 times 4.156 will be equal to 8.2524 keeps fit. For moment CB, also you know it's a roller, so it is 0. Now the question is solved. It is just written to find the moments. If it is if there is a sideway, you are just going to find the moments. I don't think so that they are going to be asked to find the shear and the moment diagrams. And now the question is that. Thank you for watching me. Please, if you like these videos, if you want to see more of the videos, please subscribe and share and comment. I'm going to try to do the best one. Thank you for watching me. See you for the next video.